Hi, I'm Charles, and welcome to part 22 of the OpenSCAD video series. In this part, I'm going to be talking about a technique called a surface hull. This is a continuation from our video about chained hulls, and as far as I know, this is the first tutorial where the surface hull technique is detailed. It is used for creating a large variety of shapes that were difficult to create before without it. Let's get started. So, essentially what a surface hull is it's kind of like a triangle mesh, which it's essentially what we're going to be creating, a triangle mesh of shapes that the hull command allows us to put together in a specific way. So if we look at a triangle mesh, we can see something like this dolphin. We can see that they're triangles. It's just made up of a bunch of triangles. Same with this more organic shape. This graph. So we're going to be using a similar idea to this, or essentially this idea, except to create solid shapes. See, same with this bunny. So, yeah. So I'm going to show you how to do this in OpenSCAD. So we bring up OpenSCAD, and I created a picture for this. So essentially, what we're going to want to do is say we have a point. And we have a three-dimensional function which takes two values, an x value and a y value, and returns a z value. Then we're going to want to hull a triangle. Just like this. So, let me start by giving some sort of demonstration. So, we're going to create a step. I'm just creating a function right now. So we're going to create a function that we maybe want to hull to get a representation of. So we're going to say P and Q. And now we're going to create a double for loop for two variables. So I'm going to give you an example of this function. This is a three-dimensional function. It takes two inputs. So P and a Q, or an X and a Y, whatever variables you need, and gives you one output. Okay, now I need to create X and Y. So essentially what we're doing is, so A and B go from -1 to 1 by our step, which is 0.1. And we are going to create X and Y. They will be A times 2 the 2 variable, as in it's going to 10. So X will go from -10, because -1 times 10 is -10, to 1 times 10, which is 10. So X will go from -10 to 10, and Y will go from -10 to 10 as well. So if we do this, if we run this, I've forgotten some square brackets here. There we go. So, as we can see, hold on, maybe I should make step times 2 to make them the proper size. Okay, so as we can see here, we have a sort of grid. If these were all laid flat, it would just be a grid of cubes. And what we've done is for each of the values, each one of these cubes, we've moved it a different amount in the z direction, which corresponds to our function f. So what we're going to want to do, maybe I should make these a little bit smaller, just so that it's clear, is we're going to take, so we could just look at this set right here of 4. 1, 2, 3, 4. Or we'll start 1 here because this is right at the origin. So we want to make a triangle. Let's bring up our picture again. So each one of these points represents one of these squares, or cubes. Each one of these cubes is a point. So we have just our normal point, and then we have the next one in the y direction, and we have the next one in the x direction, and then we have one cube that is both next in the x direction and the y direction. So we know this one has a value of whatever x and y is. We know this cube up here has the same x value, but y plus some step. Same thing for this one, it's x plus some step and y. And this one is the x plus step and y plus step. So, what we're going to do is the ones that are represented by the blue triangle, we want to hull these together. 1, 2, 3. And the ones that are represented by the purple triangle, we want to hull together 1, 2, 3. So that we get a continuous shape. So essentially what we need to do then for that is we need to make multiple different cubes. So I'm going to demonstrate this, how to do this. So first we need 2 more variables. We need x plus step, and it's going to be x xps is equal to a plus step times 2, and next we're going to create y plus step. Times 2, our 2 variable, not the number 2. So let's so we have our first one. I'm going to change the size to a vector so it's more visible. So this is the normal one. So we'll say step, maybe 1. Okay, and so for our first triangle, we have our first one, and now we need 2 more. We need the x and y plus step, and the x plus step and y. So we're going to create those. We just copy and paste. So I'm going to add some comments just so it makes sense. X and y. X and y plus step. And x plus step and y. So we just need to change some variables around. So we know this one is the y plus step, so we'll add the y plus step variable. and it needs to go in both here and in the function as well. And here we need to check it to the x plus step, and here to the x plus step as well. Okay, so now if we look here, you see what happens. Well, the shape has changed, but we don't see much else. So let's change these around so that it's clear. Okay, so now we have a grid. You can see that we have some extra ones on the edge over here, but don't worry about those for now. So if we look at, we were facing this direction, we can see that we have all three cubes or objects on one place and then the next place. So now that we have this is a good start. This might be a little bit confusing to see all of these at the same time. So let's see if I can, maybe this can go from 0. Maybe that will make it clearer. There we go. So we have our original one, and maybe if we just go to 0.1. Point 5. Well, that's okay. So we have our original one, and then we have this one right here is this one, and this, the y plus step, you can see it's in the y direction, so this thing going this way. The vertical one is just another copy of this one, and it refers to the next coordinate plane. We don't want to worry about that right now. So the one going along the y-axis is this one over here, and the one going along the x-axis, which is right here, is this one. So we have all three. We have all 3 points, making a triangle. And now, maybe I will take this back to 1, so that it's clear. Again, we can see, and it's matching our function just as we want it to. And now I'm going to change all the sizes back to just say step. So that's probably a good, it's pretty small, but that can be a custom value. The size can be a different value. So now that they all look the same and we have multiple cubes superimposed on the same place. So what we're going to do now is we're going to hull these 3, and that's going to create a triangle like this. And hopefully it'll make more sense when you see that. And as you can see, we have created a triangle, our lower triangle, just like in the picture here. We've held these 3 cubes together, these 3 points, and created a triangle. And that's happened for each of these triangles. And that works on the opposite side too, if we set these back to -1. So we've got an organic looking shape right now, but there's a problem, is that it's got a ton of holes in it, and we don't want a ton of holes in our shape. So we need to create the upper triangle as well. So how we create the upper triangle is we just make a few more. Essentially, we just have to change one value. So we can copy this, paste it below. Here, let me comment this as the lower triangle. And this is the upper triangle. Okay, so the only thing that needs to change, if we look at our drawing, so our original triangle, it has the XY, the X and Y plus step, and the X plus step and Y. You can see all of these right here. So our upper triangle, the only thing that's different is instead of X and Y, we have an X plus step and Y plus step. So we're just going to change that right here. Change XPS, YPS, and in the function as well. So now when we do this and hit F5, our function gets filled in, and we have a we've got our shape that we were going for, which is great. That's what we were going for, and we can change the it's probably important to really specify the size of each of your cubes. So I'm just gonna go and change that say 0.05, because the finer you make it, the better it looks. It's harder to differentiate. So we're just gonna change that to S. Whoops. I forgot a semicolon. And this is a little bit, actually it should be about the same, so I don't know why it's taking time to load. But there it is. If we make this smaller, if we make the two portion finer or smaller, we will see that the mesh inside becomes finer because the step doesn't change. Just in the way that everything's set up here, we have A times 2 and B times 2. So you can see that we have a smaller but finer mesh now. Let's make that a bit bigger. Oh no, that would make it smaller. Yeah, that's gonna make it shorter. Let's say 5. Now, if you want them, your objects really small, it's gonna make this this object really thin, which might not be what you want. So I'm gonna show you how to make it thicker, to add some a thickness to it that you might want. So essentially what we do is we can just copy and paste these. And we're going to add some height to them. So some constant. Let's define it here. Extra height. Let's say we want our object to have an extra thickness of let's say 5 units, 5 millimeters. So we're just gonna add extra height, not in the original one, just in the second one. So where our Z value is, we're gonna say plus extra height. We're just gonna add that to all of them. And I'll just do this for the first set of triangles, the lower triangles, and then I'll show you what it looks like for the next set of triangles in a second. Well, maybe that's a bit much. 5 is a bit high, but you can start to see what's happening. To illustrate the point, maybe I'll just make this 1. And now I will add the other ones. Plus extra height. Okay. So perfect. As you can see, we've added some height to our model. How much is up to you? And we've created a shape that would have been difficult to create before. OpenSCAD does have a surface primitive, but you need an external data file. Whereas here you can write everything in OpenSCAD. And this is even more liberating because you can use this to create different shapes using different coordinate planes. Say if you wanted to use cylindrical coordinates or spherical coordinates, a similar idea to this applies. And I might do a video on that in the future. But for now, this one's probably good. So I'll just demonstrate a different function right now. I'm going to do the cosine function of the paraboloid. We'll see how this turns out, but I might need to change some values just because it can get rather difficult rather quickly. Okay, well that's kind of not super detailed, so I probably need to change this. Let's see, maybe if I make this 0.2, it'll be a little bit faster. There we go, that is a bit faster. Maybe 20. Start to see what it looks like. I'm gonna change the extra height, maybe to 0.5. You might be able to see it's a little funky over here. I think that's because there's some extra, yes, in this direction. So if we want to fix that, we can just subtract step. There we go. And now it's symmetrical. Perfect. Yeah, there we go. That's it's much better representation, and I will increase the step so we can get a better view of it. But I don't want to spend the whole video loading these things, so I'll maybe make them simpler. There we go. That's kind of the cosine, the 3D cosine function. That's a little wonky on the edges, but you can make it really fine if you want to. But this is as fine, I think, as I'm going to go for this video. But yeah, that is the surface hull technique. Now, there's one other thing you can do with this. You can set the z values to 0. So maybe you just want the graph from the XY plane up or down. So you can just I'll set these I'm going to save it now, but I'm going to set these to 0. Yeah, and we'll see what that does. Really should have created a variable for this. It made it, actually, you can't really create a variable for this. It's kind of complicated. So those were the extra ones. These, we still have our original ones. I'm gonna wait for that to load. And as we can see here, it's completely filled from the XY plane up and down. Maybe that doesn't make sense. We can go back to the original function that we had so that it's a little bit clearer. P times P plus Q times Q. This is a paraboloid over 2, I think it was. And there we go. We can see that from the XY plane up to where our function is created, it's solid. And that's essentially what we were going for. You can also do this with a constant value from above. If you just set it above, you could make it solid from above as well. But yeah, I think that's probably all I'm going to do for now. I think that explains the idea pretty well. Let me know if there's anything to be changed or something I can do to make this clear. And anyways, thank you for watching, and hopefully I'll see you in the next one.